Hello, can we start now? Hmm. Hmm. Okay, so if nobody else is joining, we'll start in our usual format. So today we'll first recap the contents of week 6, which was on scanning electron microscopy. And after that, in the last half an hour, we'll focus on the assignment. So I have again prepared some questions pertaining to this week's content. You can try solving this after this doubt session. Okay. The previous week's content was on the continuation of TM, transmission electron microscopy. Now we'll look at SEM, scanning electron microscopy. Yeah. So initially also we had in some of the initial lectures we had discussed what is the difference between SEM and TM in terms of their uses. So I think we had discussed that SEM is more suitable for getting information related to the surface topography as well as some composition related information, and TM gives you a more it gives you more information about the internal structure of the material, and that too at very low atomic length scales. So for example, you can have a resolution in angstroms or nanometers, while in case of SEM, it is in around hundreds of nanometers and above. Actually, in SEM also you can get to tens of nanometers. Also, there are some similarities between the instrumentation of SEM and TEM. Both of them have similar components like the electron gun, which is used for generating the electrons, the lens system, such as the condenser lenses, objective lens is also present in both, and then the vacuum system that is required for operation. Mm. So SEM resolution can be as much as 1 nanometer. Also, in case of SEM, we have the term scanning in the name. So from that itself, we can get some idea that there is some scanning motion involved. So for those who are not aware, in SEM we have an fine electron probe, and it is scanned over the surface of the specimen in a raster fashion. So this will again be shown in pictorially in the subsequent lecture. But by scanning in this fashion, the information or signal generated from each point is mm, shown in an image, and based on the information, the signal that comes out during scanning, it is correlated into the it is transferred to an image, and then you and in that manner a whole of a scan area can be seen on a computer screen. For example, here we can see one of the examples of how CM images look. This is for pollen grain. So we can see that the surface of these grains is very much visible. That the curvature, the protrusions are all very clear in this image. So from this you can tell that the depth of field is very high for SEMs. Also, we have something called environmental SEM and variable pressure SEM, which are some variants of the SEM for spatial samples, for viewing spatial samples. Now, the SEM was actually constructed, interestingly, after TM. Mm. It was constructed by Arden in 1937, and basically it used the same probe which is used in TM, but it did scanning of a thick specimen instead of transmitting it through a thin specimen. And by collecting the signals that were generated, they were able to generate an image, they were able to generate an image of the specimen. In SEMs, the electron energy is usually 1 to 30 kilo electron volt, while we have seen that in TEM, it is about 100 to 300 kilo electron volt. Why this difference is there? You can think about it yourselves. It has to do with the transmission that has to occur in case of TMs. Also, there can be different kinds of gun which can be used. All have their benefits and trade-offs. Hmm. So yeah, this is the arrangement of the components of the CM. These are all as we have in TM, but here additionally we have scan coils which can control the electron probe movements, and we do not have anything below the specimen. Here we have detectors of different kinds which can capture the signals generated. So I was talking about rastering that happens in SEM for scanning over the whole of the specimen or your selected specimen area. And there is a one-to-one correspondence between the rastering that happens on the specimen using the fine electron probe and the image that is generated on the screen. So as the scanning is taking place, immediately there is image which is being generated in the screen, and that is also being generated in a raster fashion. And the way magnification is achieved in SEM is different from how it is conventionally done in TEM and optical microscopy. So here the magnification does not occur by changing of the lens strengths, that is by changing the focus. In case of SEMs, and there is a fine probe just resting on the screen, and based on the scan area and the area which is being shown on the CRT display, the magnification is calculated. So if the area being shown on the screen, because the size of the screen is fixed, right, and if the area being shown on the screen, specimen area being shown on the screen is smaller, that means that more magnification has been done to show it on the whole screen. So basically, SEM's magnification happens just the way it happens, just by zooming in on the specimen image and not by changing any of the lens systems. So the lens system or lens strengths are not altered. Just zooming in of the on the CRT display takes place. We have already discussed in brief about the interactions that take place in SEM in between the electrons and the material. So we'll again look at it now in more detail. The interactions can be of two kinds, inelastic or elastic. So we have already seen that the elastic interactions do not involve any loss in energy. That is the major difference between elastic and inelastic. And inelastic interactions involve some loss of energy of the electrons. Now, within inelastic scattering, there can be multiple modes of scattering which lead to a loss of energy of the incoming electrons. So, because you can try to visualize it, if you have a specimen on which incident electrons are being bombarded in a way at a very high energy, then we know that there will be some elastic interaction, that is the electrons will move will interact with the specimen with the atoms and move away in some other direction without losing any energy. But a lot of the electrons will stop somewhere within the sample. They will lose all their energy, and this happens by the inelastic scattering phenomena. So the first kind of inelastic scattering is phonon scattering, and what happens here is that due to the incoming electron, there are some atomic vibrations which take place, And so, as the incoming electron interacts with the atoms of the material, some it causes some atomic vibrations of the atoms, and through this route there is some loss of energy in the form of heat, since the atoms are vibrating more um, more heavily due to this incoming electron. But this loss of energy has been observed to be less than 1 electron volt. It is small, and the mean free path for this is quite large. So we had discussed about mean free path. If the mean free path is large, that means that the interactions are less common. It's the electron will go through higher distances before having interaction before having subsequent interactions with the material atoms. So since the mean free path is high, it is of the order of microns. This is uh, less common, this kind of scattering, and because of this, this is of not a lot of relevance for us. Additionally, another thing about it is that it leads to deflection of the electron by a high angle, which can be around 10 degrees. Another mode of scattering is plasmon scattering. So we know that most materials, like atoms, have a cloud or sea of electrons around them. Especially in case of metals, we have free electrons, free electrons around the atoms, which can move freely. And it is due to these sea of electrons that we see conduction in metals. So when the incoming electron interacts with these sea of electrons, it can lead to generation of some electromagnetic radiation, which is called plasmon scattering. So for all of these, the loss in the energy here it is 5 to 30 electron volts, which is significant, and the mean free path, which is uh, low in case of plasmon scattering, it's in few hundred nanometers. So these two terms are important, the loss and the mean free path, so that you get an idea of what impact this scattering can have on your detected signal, because all of these phenomena are taking place simultaneously in SEMs and TEMs. So by knowing uh, such information such as the energy loss and the mean free path, you can get an idea of how important that scattering event is. Then we can have single valence electron excitation, where instead of loss of energy to the way sea of electrons, which happened in plasma, it only the loss only happens to one electron. This is also not very useful for us. It does not give us much of any useful information. Then we have inertial excitation. So in case the incoming electron knocks out the electron from the inner shell, that is the K or L shell, then in that case the atom gets excited because it has one electron less, so it's in an excited state of high potential energy. And to relax, one of the electrons from higher shell will try to move to the vacant uh, the shell having the electron vacancy, and this relaxation will lead to since there is a reduction in energy when this happens, this will lead to generation of energy in the form of X-rays, electromagnetic radiation, and depending on the shell in which the vacant atom was and the shell from which the electron moved to the vacancy, there will be a characteristic X-ray of characteristic wavelength which will be generated. This also has a quite high mean free path, and so this is also there. But since we have usually have a good amount of current that we give, this phenomena, even though it is rare, is still very useful for us for getting composition related information. Since the X-rays which get generated are characteristic for the atoms from which they are being generated. If in case there are any doubts, you can let me know. I am just going very briefly over the slides. I'm hoping that if any of you have any doubts in any of them, we can discuss a bit more. So the effects which are observed, since I have told you there are detectors kept outside in the SEM, which are able to capture the signals which come out from the material in term, which can come in the form of electrons having some energy or in the form of electromagnetic radiation. These detectors capture it and try to interpret the information, and all of this uh, a signal that comes out is called secondary effect because it is caused by the primary beam and its interaction with the specimen. Now I had told about excitation of atoms due to electrons in the inner shell getting knocked out, or it can be from the outer shell also. But when electron gets knocked out from the inner shell, the excitation is much more, since the inner shell has electrons having higher binding energy. So for once the atom is excited, to reduce the energy or potential energy of the atom, electrons from outer shells will jump to the inner shell. So if for example it happens from L to K shell, there will be an electron, there will be a generation of X-ray having some wavelength corresponding to this transition. But along with this, there is also a possibility that there will be some, I think it will be explained later, but I'll just briefly tell now that the energy which will be generated due to this transition in the form of an X-ray, it can excite another electron in the same atom, and that electron can leave the atom with some amount of energy. And if that happens, we call it OJ electron. But emission of an OJ electron is much also. Another thing to keep in mind is that many a times it can happen that the transitions which are taking place are not in the inner shells, because it might happen that the electron which got knocked out was from an outer shell. So even if that happens, there will be some electromagnetic radiation which will get generated, but that will be of a lower energy, that is of a higher wavelength, and all those radiations are called cathodoluminescence, because many a times they have energies which are close to visible light spectrum, and they are not of much use to us. Hmm. So I have told that based on the energy difference of transition, now based on the transition energy, we can identify which is the element. This is the basis for EPMA, electron probe microanalysis, and similar methods such as EDS and WDS. Hmm. Okay, so I have already discussed OJ electrons. Here, once a electron gets knocked out, instead of just an atom transitioning and a characteristic X-ray getting generated, the X-ray which the energy due to the transition leads to a release or emission of another electron in the same atom with some energy, and that is called an OJ electron. So this is a very important plot. It is between intensity and electron energy. That is the energy of the electrons which are generated from the specimen or which are detected by the detectors. So these electrons can be secondary electrons which are knocked out, or some other electrons like OJ electrons or backscattered electrons which undergo elastic scattering with the atoms of the specimen. So all these atoms which are knocked out are called secondary electrons. Uh, so those electrons which come out from the surface with an energy lower than about 50 electron volts are majorly secondary electrons. At slightly higher voltage, some OJ electrons and at slightly higher energies, some OJ electrons are detected, and those which have a very high energy are the backscattered electrons, because they have not lost uh, much energy. They have just undergone majorly elastic interactions, scatterings, and so majority of the intensity comes from BSEs and SEs, and very little from OJ electrons. Also, the atomic number of the elements which are in the specimen also affect how much of the signal will, how much surface, sorry, how many secondary electrons will be generated, how many OJ electrons will be generated, how many backscatter electrons will be generated, and all of that is mentioned in the slide. So this is a Monte Carlo simulation which we have discussed earlier also. Here you can see that no trajectory is going in a straight line. There are all kinds of curviness we are seeing. So multiple scattering phenomena or occur for every electron. That is what we expect. And because of this, we get all sorts of signals. The volume within which majority of the electrons have lost all their energy is called the interaction volume. Hmm. So now we have already, I have already told what are the secondary electrons. This part should have come before in the slide. So the content arrangement can be improved a bit. So these are electrons which escape from the specimen with energies below 50 electron volt. And because they come out with very less energy, they are knocked out electrons basically. So because of that, only those electrons which have been knocked out from close to the surface are able to overcome the work function and escape from the surface of the specimen. So all the SEs which get generated majorly are coming from close to the surface and give very high spatial resolution of the surface. They could either be coming due to interactions of the primary electron beam with the specimen or due to interactions of the BSE electrons which are coming from at different angles from within the specimen. So when the BSE electrons are coming out towards the surface, near the surface there can be some generation of secondary electrons which can take place due to knocking out of electrons, and that can also cause secondary electron emissions which will be a bit away from the position of the primary electron probe, and these are called Se2, the ones coming from the primary electron are called Se1, and then we also have Se3 and 4 which I will discuss later. Okay, so Se3 we can see here. So Se3 are those secondary electrons which get generated not from the sample but from the other parts of the SEM machine. For example, the container of the machine or some components in the machine. What happens is that the backscatter electrons, which have very high energy in kilovolts, they can cause secondary electron emission from other parts of the machine. And also when the primary electron beam is interacting with the lens arrangement system or the columns of the column of the microscope, that at that time also the primary electrons can cause some secondary electrons to get emitted, and that can also be captured by the detector. So these are all noise which get generated during SEM. But if the SEM is well made, then usually this is quite insignificant. The yield of secondary electrons which get generated from the primary electrons due to interactions of the primary electrons is called del, denoted by del, and it tells how much secondary electron emission happens per primary electron which is being which is reaching the specimen. We have already talked about the elastic interactions which leads to backscattered electrons. Due to Coulombic interactions. We have talked about Kikuchi lines when we discussed TEM. And here also a similar principle of diffraction takes place, which leads to backscattered electrons getting generated at particular angles, uh, which are the diffraction angles. So they can give information related to the orientation of the grains at the surface of the specimen based on the diffraction angles, which can be calculated by analyzing the Kikuchi maps generated. And this is exploited or taken benefit of in electron backscatter diffraction technique, EBSD, which can give information related to the orientation of the grains at the surface. Hmm. Hmm. I think we have not talked about the electron gun arrangement, so maybe we can spend a bit of time on that. So it's not shown here, but in an electron gun we have basically a filament in case of thermoionic uh, gun, which is heated at using a filament current of a high value. Due to that heating, electrons get generated. Okay, we talked about it when we discussed about Van grid, and we discussed that we have an anode which is used to accelerate the electrons which are generated. So we have already discussed this for both thermionic emission as well as field emission gun. Mm. So now we can look more closely at all the signal that is coming, being generated and detected in an SEM and where they come from. OG electrons come from very near the surface. Secondary electrons are also from close to the surface. Then the BACs are from within 500 nanometers. Those which are from deeper are usually not able to escape out of the surface. They get attenuated as they move in the sample. We have characteristic X-rays which interact lesser with the sample. They have a very high mean path. Because of that, they can come out from the interior of the specimen. Then I have talked about cathodoluminescence, which is due to the transitions in the outer shell of the atoms. Also, we have something called continuous X-rays, which is also called Bremsstrahlung, and this is due to um, the deceleration the deceleration of the primary electron beam as it interacts with the electrons with the atoms, the electrons and the nucleus of the atom, because due to the forces it experiences, the primary electron tends to decelerate, and that deceleration also leads to generation of loss of energy as X-rays, which can be of a range of wavelengths. So because of this they are called continuous X-rays. Based on the loss of energy, we can have different wavelengths of the X-ray being emitted. And the volume in the material that contributes to the detected sample is called the sampling volume. while that volume in which that volume within which the electrons are able to penetrate is called the interaction volume. So what is more practically of use for us is the sampling volume, because that is from where we get the information of the about the specimen. X-rays, as I have told, have a higher mean path and have a higher sampling volume. PSEs come from much deeper in the within the surface, so because of this they have a worse spatial resolution, because they give inform a more broader information of the depths of the which, so they give a more broader information since they are also coming from the depth of the specimen. In case of SE, secondary electrons, they are majorly coming from near surface regions. Because of this, they can give much higher spatial resolution, and so all the information or the signal that is coming is from near the surface only. And for them, the sampling volume is almost the same as the interaction volume. Here we can see in these images that the left image, which is for SE, gives much better topographic information. The depth of field is higher. We can see which regions are above and which regions are below. The contours are visible very well. While in case of BSE, we can see a more of a 2D image and not a 3D image. But in BSE, we can see the contrast due to atomic numbers very clearly, which can't be seen in the case of secondary electron imaging. If there are any doubts you have, you can let me know. Now we'll talk about another important aspect of signals in SEM, that is the yield due to different phenomena. So in case of secondary electrons, we denote it by del. For BSEs, we denote it by eta. Mhm. The BSE yield is more strongly dependent on the atomic number compared to the secondary electron yield. This can be somewhat understood um, if we see the difference in how the BSE and SE electrons get emitted. BSE electrons get emitted due to interactions, or they are not being emitted. BSE electrons are generated due to interactions of the primary electron with the nucleus of the atom, and the nature of the nucleus has a strong effect on the BSE electron generation. So as atomic number increases, the size of the nuclei increases, and more the probability of BSE generation is much more. In case of SEs get generated by knocking out of the electrons, usually from the outer shells, so they are not as much affected by the atomic number. The total number of electrons that get captured uh, by the detectors is can also be compared with the number of electrons which are in the primary beam and are interacting with the specimen. So the total electron yield will comprise both of SE electrons and BSE electrons which are generated from the surface and collected by the detectors. And if we plot it against accelerating voltage, it comes out to be something like this. So initially there is an increase in the emission with increase in accelerating voltage, but afterwards there is a decrease. This could be because as the energy of the primary electron beam increases, the scattering cross section reduces, so it is less likely to get scattered both elastically and inelastically as its energy keeps increasing. Due to these, the generation of Se and Bse electrons can reduce, and as a result, we see a lowering. And initially, we can understand that as the incoming electrons have very low energy, they are not able to knock out the electrons, or they get their energy gets lost within the material. So Bse electron emission is also low, and as a result, the total electron yield is low. Hmm. We can see that for some regions of in the accelerating voltage range, we have a yield which is greater than 1. So in case of non-conducting sample, there will be some charge accumulation. That is, there will be negative charge getting accumulated on the surface in this region, while in other region there will be positive charge accumulation. So to avoid that, if that happens, then the incoming electrons will get repelled or attracted by the surface and surface charge, and so your the signals will which you receive will be distorted and you will not be able to form a good image of your specimen. So, and to counter this, what we can do is make the specimen conductive by coating or operate at these particular accelerating voltages where there is no charge accumulation or reduction. Now, secondary electron yields can also depend on the atomic number. So we have seen that the dependence is low. Also, the Bse electron yield can depend on the atomic uh, on the energy of the primary electrons. As the energy increases, the yield Bse yield decreases, and it also depends on the atomic number more strongly than the Se electrons. Additionally, Bse yield is less dependent on the voltage. The deviation due to voltage is lower, while the Se yield is more strongly dependent on the voltage. With this, the week's content is finished. This week the content was less, so if there are any questions, we can address them now. Else we can move on to discussing the assignment. Mutyalu, you have a question. You have raised your hand. You can unmute and ask me.
Yeah,
Yes. What is
yeah,
your
Abhinav,
question?
yeah, yeah. Question and my small doubts also there.
Okay.
This is can I speak once? My introduce that your name is lecturer that Abhinav Chand.
Yeah, yeah. I am Abhinav.
Yeah, yeah. Thank you, thank you. The first time actually, why? Because this is a Muchalu Sonnapu from Vishakhapatnam.
Okay.
Okay, this is the first. Actually, last 3 4 weeks. Actually, this is the week six, no, or week five.
This is for week 6.
Yeah, that's actually my that week first and second. I am not joined up to five. It is myself is not joined.
Okay.
Not joined due to some
Hmm.
my personal last 2 weeks. Actually, first
Hmm.
week and second week. Actually, I am not doubt that the teams. I am not working that some network issue for that this month August first week or second week.
I see.
As a fourth and fifth also, it is present is a rain, very rain is in that Andhra Pradesh.
Hmm.
Some
Yeah.
some disturbance is there. This is the that's why I'm actually first week. This is a first week, sixth week. Actually, I joined the first
I
week.
see.
Yeah, yeah.
Okay.
Yeah, yeah.
Okay. I see.
I tried to that last few fifth week and fourth week also. I tried to that. Actually, my network is a little bit poor condition network. I will
Hmm.
plan for Zoom or Google Meet only
Oh.
myself. Okay, this is the
Okay.
Teams, my office network. That point of view, little bit in
Hmm.
means first of all that little bit problem. Whatever is that time time not bound that 3 to 5 o'clock.
Hmm.
Little bit meeting point of view, little bit
Yes.
hurdle
Yes.
is there. That point of view. Can I help last one to fifth weeks or lessons, if any possible for that? Send it my WhatsApp or if any possible of any possible which area I will took download that my assignments also not submitted that point of view. If any clarify that, please within the next 3 few days back I will submit to entire sixth assessment. This is my
Okay.
doubt, sir. Yeah, please, if it is possible, if anything.
To submit it
Yeah,
now.
yeah.
Okay. I
online
think.
online also my online also little bit difficult. So this is the first time that online courses, first time
Hmm.
my side if any direct offline only at the university point of view. My side is btech chemical and mtech completed, that mba completed. This is the phd point of view. My goal actually, I am also chemical engineering from jn university, that
Oh.
hyderabad,
Okay.
that
Okay.
I am working that Milan
Hmm.
Pharmaceutical last 17 years. My working.
Oh. Okay. I see. Okay.
This is the my goal for PhD for chemical engineering. So that's why please
Okay. I see.
any put in that your side help some to lead to that how to meet that last 5 6 this 6 month, how to possible completion. Please need to some guidance. Please that point of view I need some help.
Okay. I see. So Mutyalu,
Yeah.
from what I know, NPTEL has some. So right now, maybe the assignment deadlines might be passed, at least for the initial assignments.
Okay.
But there are some officials of NPTEL who you
Okay.
can maybe try to contact. Just you can mail them. If it is possible, they can help you submit it a bit delayed submission. They might allow.
Okay.
Also,
Who
mhm.
Yeah, yeah. Tell me, sir.
Yeah, yeah. Also, I was saying that the recordings which I am doing weekly on Saturdays, they are available on YouTube. So even if you have network issue, you can see there, and all the assignment discussion is there.
Okay.
Also, what I'll suggest is that these assignments have somewhat lower weightage. The main
Okay.
examinations and tests have higher weightage. So even if you still can continue with the assignments which are being given now and do the tests and exam well, then also you
Okay.
will be doing well overall.
Okay. NTPL,
I think.
if anything, communication point of view, some person or
Mm-hmm.
mail, if any available, sir.
Mm-hmm. Um, I'll have to check the NPTEL website. I also am not sure about that because
That is my
NPTEL is
big
a
problem.
NPTEL is a separate government body which
Okay.
takes care of all the conduction. So I
Okay.
am just helping them with the doubt solving. I'm a PhD student.
Okay.
But I think in if you see in the portal, there might be someone who will be in charge.
Which portal? NTPL portal.
NPTEL online portal. Yes.
Okay.
Mhm.
Those are my expectation. You are all also everything everyday guest type or continue to engage with NTPL, Bino.
Sorry, can you repeat?
You are that continue NTPL lecturer, no, for that online courses, online giving the lecture.
Mm-hmm. Yes, yes.
Correct. Total technical of material characterization, no. This you are handling with.
So the lecture is being given by the professor, Professor Shibayan Roy. I am a PhD student who is doing teaching assistantship. So I am helping every Saturday on
Okay.
this doubt discussion session. So my
Okay.
involvement is only in the doubt discussion, but I can help you, maybe guide you if you are not able to find who is the responsible NPTEL staff who can help you. But I
Okay.
think you
Out. Main professor is that Shibam Roy, no.
Shibayan Roy, yes,
Shibam Roy is a main guide, right?
yeah, yeah,
Yeah. You're also
mhm.
that you can the PhD scholar.
Yeah, yes,
Yeah. He is a Kharagpur for IIT, right?
yes.
That is my doubt. That is why, because
Mhm.
actually whenever is my apply that fees details everything, the details sent to that metallurgical material engineering for that Professor Shubham Roy, right?
Yes, yes,
This is the technique of material characterization, of course, right?
yeah, yeah.
This is the handling what to Shubham Roy that. So
Yeah.
how can reach that if it is possible, Shubham Roy, Professor Shubham Roy? How can, if any mobile number, if any WhatsApp mail ID?
Mail ID you can get from the IT Kharagpur department website,
Okay.
but I think he'll be very busy.
No,
There
no,
is
no,
a
not,
live
not,
interaction.
sir.
There is a live
I am not,
interaction session that happens. There you can contact him, I think.
when possible that live interaction for any course. I mean, if it is possible, he is come to that any one of 12 weeks. May any one call is available. That sir.
There will be live interaction again, maybe after 2 or 3 weeks. But do you have any technical doubts you want to ask or related to the assessment, like assignment or the test?
Yeah, yeah. No, no, no. I will interact with
Mm-hmm.
you. Not an issue that I will wear that.
Mm-hmm.
That my doubt is whenever is NTPL, I will relook that. Actually, his name is just now she that. That's why I'm asking. Professor
Okay,
Shubham
okay.
Roy, that I think not in that everything. What you, my any doubt also asking with you also. Not any problem. Yeah,
I see.
yeah,
Yeah.
yeah. Correct, correct. If it
So
is
what I'll
possible,
do is, yeah, I'll quickly show you the screen of the NPTEL portal. Maybe from
okay,
that it will be easier for you. After
okay,
that, I'll discuss on the assignment of week 6. So you
okay.
can see my screen now.
Yeah, seen man. Right.
Uh,
Abhinav Chandrakar.
yes. Okay.
Yeah, Ananta Jennifer. Who is Anita Jennifer? Yeah, just coming that.
Mhm. So this is the portal you can use for submitting the assignment.
Which portal, sir? Your screen also
Yeah,
just
yeah, yeah.
now.
It has now you can see.
Yeah, NTPL Swayam portal.
Yes,
Yeah, Swayam
and
portal go.
here in the announcements you will get to know about the live interactions. So
Okay,
we had it I think last week. Yeah, we had one live interaction last week
okay. Your sir, your live interaction last week.
with Professor Shibayan Roy. It was on
Oh,
21st
that's good.
August. It will
Okay,
happen
okay,
again after some time. So at that time
okay,
you can interact with him.
okay, okay.
Also, there might be some information uh,
Sir, which is yeah, yeah.
related to the assessment and uh, how you can submit the assignment.
Yes.
So it's written that you have to just the best 8 assignments will be taken out of 12 and it will have 25% weightage.
Okay,
Then you will have a proctored certification exam and that will have a weightage of 75%.
okay. Doubt. My doubt is first to fifth assessment where is going on.
Yes.
I will select. That is my doubt.
First two, sorry, can you repeat once?
I can my first to fifth assessment
Hmm, hmm, hmm.
assignment. Where is I look that? Where is I look that?
I'm not sure. Maybe the deadline might have finished for the first few assignments. I
That
can
is
check once
yes, please.
because there are large number of students who are participating, so they have very strict deadlines about it.
Yeah, yeah, please, if it is possible. Yeah, week one.
In the announcements, it will be there. Okay, it's here. So this is already week 5. Deadline is already gone. It was 28th August.
Okay, if
Week
anything possible.
uh, about that I cannot tell you.
Okay.
Um, so I think even if you start with this week's, you'll be able to finish 6 out of the 12 assignments, and the
Yes,
best
yes,
8 are
six.
you will
Yes,
not be
Chandra.
losing
Yes,
too many marks.
correct, correct, correct.
Mm-hmm.
Yeah, I whenever go first of all, this your screen is open. Sixth. This is the today
Yes,
class is week sixth, correct?
week 6. Yeah. So
Yeah.
after this session, you can directly go here and fill your choices and submit it.
Okay. Okay. This is the week sixth ka exam today. Deadline is tomorrow, no?
Deadline for this is 4th September.
Fourth.
So
Okay.
4 days
Okay. I
from
will. Okay. I will go
now.
directly that Swayam courses NTPL. First go that
Mm-hmm.
year that where is question and okay about the courses. About the courses after we'll go.
I'll just show you. Yeah.
Yeah.
Mhm. So you can go to Swayam portal, log in with your account details.
Okay. Okay. Okay.
Okay.
Okay.
Once you have logged in, it will show
Okay.
you the list of courses for which you have
Okay.
enrolled. So here
Okay.
you just go to that course, Techniques of
Okay.
Materials Characterization.
Okay. Okay.
Once you're inside, you go to week 6. Then
Okay.
here you have the lectures, video recordings, the slides,
Okay.
for downloading, and then after that you have the quiz.
Sixth week quiz. Okay.
Yes. And here
Okay.
you can fill in whatever options you might choose.
Alphabetical. Okay.
Alpha, yeah, yeah, from 1 to 15, and just
Okay.
submit it. That's all.
Okay, okay. If it is a up to below fifth, what can, if any possible, what I am office NTPL, if it is any possible for mail ID that or any WhatsApp number for discussing for a previous
Mm-hmm.
assessment purpose,
Previous
if
assessment.
anything, please let me that
In
channel.
case I come across, I'll let you know. Right now, I am not sure.
Okay,
Mhm.
if in please inquiry
Okay.
that if it, I will touch with
Sure.
you that if it is possible, this is Abhinav. Please, if it possible, you send your number.
I cannot
Uh,
share your number. You can give. You can chat
If
with
it
me
is
on
possible,
Teams
if it
only.
is possible, if it is
Mm-hmm.
possible, your WhatsApp number to better to that. If any doubt point of view that I will reach you. If it is not, I am dust of that. If it is possible, give your WhatsApp number if it is possible.
No, no, it's we are not allowed to share the numbers, but we have a discussion forum also for this purpose only, so that you can share your doubts as well as
Okay.
other students can look at your doubts and discuss.
Yeah.
So
Yeah.
there will be a link to that forum in the NPTEL course portal. From there,
Okay.
you can post whatever doubts you have,
Sure.
because I understand that this course is new to you. This is an online application, so
Okay.
many things might not be clear. So you can just freely post it there. In case you
Yeah.
are finding difficulty related to posting in discussion forum, I can help with that. You can chat with
Sure.
me on Teams.
Yeah, yeah. Thank you, Abhinov.
Mhm. Okay.
Right, right. This is the week five, no?
Yeah. So
This
I'll
week.
open the sixth week's assignment.
Okay,
Mhm. So this question is related to elastic in scattering.
okay.
If you have any idea about which might be the correct option, you can let me know.
That week sixth. First question, no?
First question.
That elastics. This is the B occurs mostly that forward direction and involved direction of that higher angles.
Mhm. Yes, the correct answer will be forward direction and involves diffraction at.
Yes.
Actually, it is asked which will be most frequent.
Yeah.
So the correct answer should be D, forward
Oh,
direction and
occurs.
deflection at smaller angles. Because what
Okay.
happens is, if you have an atom like this,
Okay.
usually the nuclei of the atom is very small compared to the rest of the atom.
Okay.
So the mm, when the electron interacts with the nuclei of the atom, this is the nuclei which has
Okay.
nucleus, which has neutrons and protons. So when the incoming electron interacts with it,
Mm-hmm.
it will only go in the backward direction if it directly interacts head on with the nuclei. If it
Mm-hmm.
interacts at, so for example, if it interacts like this, it might go at this angle, which is a high angle,
Mm.
more than 5 degrees, let's say. But if the electron is somewhere farther away from the nucleus, it is much more likely that it will deflect by a very small amount. So usually this is less than 5 degrees. For example, in case of TEM, transmission electron microscope, the most of the electrons go straight, while only a few are diffracted by small angles. So similarly here also, most of the electrons will go in the forward direction because they will not be interacting head on with the nuclei. They'll be grazing at some distance from the nuclei, and the deflection angle will also be small due to the same reason, since the nuclei is very small compared to the rest of the atom. So the answer is D. I hope it is clear.
Clear.
Okay, so let's go to the next question.
The amount of secondary electron generation expression term of secondary election, that is secondary where BSc. This is the BSc that not background secondary, that coefficient secondary. This is the B, sir. Chand Abhinavji. This
Yes.
is the B.
Answer B.
Yeah.
Yeah, yeah. So B is the correct answer.
Yes.
The amount of SE generation is expressed as SE coefficient or yield. So
Yeah. Yeah.
how much of the primary electrons is generating SE electrons? That is called yield.
Okay.
Okay, so now let's proceed to third question.
Characteristic X-rays are used in the scanning of embryonic that triangular that contrasting that atomic number contrasting surface roughness measurement. X-ray that used for some scanning electronic sorry, for atomic number chemical resource topographical contractors. This is A, Chandgar.
A.
Yeah,
Okay. Topographic.
yeah.
No, no. Mutyalu, the correct answer will be D.
Chemical analysis.
The
X-ray. X-ray is a
Yes.
chemical analysis. X-ray. X-ray. It is a complete screening of element of measurement. No, that it is a sum for the topographical that we theta like that we are. Lab our quality control also. I will little bit that point of view select the A. Okay.
Okay.
Okay. Okay. Okay.
But
Thank you.
A is
Thank you.
topographic information, topographic imaging. What this means is that this gives you surface related information. So, image of the
Uh,
surface.
Exactly. Correct. Correct.
And this you get not from X rays, but from the secondary electrons which are emitted from close to the specimen surface.
Correct. Correct.
So,
I will. Yeah. Correct. It will come.
when
Right.
the uh, So when the primary electrons or the backscatter electron knocks out an electron near the surface, those electrons are able to escape from the surface and they are called secondary electrons. So they give very high resolution topographical information. But
Correct.
characteristic X-rays are generated due to inertial excitation of the atom. So they will give specific information which is specific to the atom,
Correct.
because the
Correct.
transition in the inner shell will the energy for that will be dependent on the atomic number. So the X-ray wavelength or the energy of X-ray which is emitted will be different for each atom, because the
Yes.
transition is dependent of atomic number. So from
Oh,
this X-ray you can do chemical analysis to know the
yes.
composition.
Thank you. Thank you.
Hmm.
Okay.
Now,
Electronics. Fourth. No. Fourth.
yes, you can attempt this.
Target electronics are generated at that surface of the spectrum and the favorited atom with a large binding electrons. Surface of the spectrum and the forward that atom is a small binding electronics. Surface of the spectrum and contain a topographical information. Bulk of the spectrum and is a forward in this the small binding electronics. Other electronics are generated of the, it is a D.
Mm, D.
Auger electronics are generated at that bulk of the spectrum. No, favored that.
No.
Either surface also one point of the binding energy
So
decreases. Either B.
okay.
My doubt
Mm,
is D or B.
okay. So
If please explain. If it my wrong, please
uh,
explain.
yeah, yeah. OJ electrons, you are able to understand how they are generated. If not, I can just show it again.
Yeah, please.
Mhm. So, sir has explained this very well in his video lecture. In case you
Oh,
are still having doubts, you want to know in detail, you can see there.
okay.
I'll open it here. Mm.
Hmm, hmm, hmm.
The generation of OJ electrons is similar. The process is similar to the generation of characteristic X-ray, but
Okay.
the difference is that when the electron from inner shell has got knocked out and the atom is excited,
Okay.
after that either there can be a transition of electron from outer shell to inner shell to relax the atom, and that will lead to X-ray photon emission, which is characteristic X-ray. But another alternate process to this is that if the transition from outer to inner shell leads to a leads to generation of energy, which causes an electron from within the atom to get released. So instead of a X-ray photon coming out, there will
Hmm.
be an electron which will come out with some amount of energy, and this phenomena is called OJ electron emission.
Oh, yes, sir.
So here three electrons are involved. In case of characteristic X-ray generation, two electrons are involved.
Yes.
So this is just an alternate uh, phenomena which can occur, and these have very low energies, and this is also very rare, so can only escape from very close to the surface,
Mhm, mhm.
and they can be used to get some extra information about your specimen. And this measurement technique is called OJ electron spectroscopy. So anything with spectroscopy means that it gives information related to the composition by looking at the spectrum of the X-ray being generated. Also, OJ electrons are more likely to be generated from lighter elements, while the X-ray generation, which is the alternate process, it is more likely for the heavier elements.
Mhm.
So if we look at the options, can you now
Mhm.
tell which will be the right one? Fourth question.
That is the A.
So it is generated from the surface of the specimen that I have just now
Correct.
told, since they have very low energies when they get emitted. So only the surface OJ electrons will be detected, but
Mhm.
also they are more likely to be generated from smaller atomic numbers. That is atoms with smaller binding energies.
That is the B.
Uh, Smaller atomic numbers have smaller binding energy, so it
Correct.
is easier
Correct.
to remove a inertial electron.
Yes, correct.
So the answer will be B.
B. B. That's why that.
Yeah.
And the question is 5. White radiation
Mhm.
X-rays. White
Yes.
radiation X-rays appears a background of the X-ray spectrum, occupies specific energy position in the X-ray spectrum, occurs in specific wavelength in X-ray spectrum, appears in a background in the EDS spectrum. This is the Caesar, I think.
Hmm.
Occurs in a
Specific
specific
wavelength.
wavelength.
Okay. Hmm.
Appears in a
Okay.
background in the X-ray.
Hmm. You understand what is white light? What we mean by white light?
White light that.
Because this is also connected to that only.
Spectrum that.
Hmm. So, in case we have multiple wavelengths, we call
Okay.
that to be white radiation.
Hmm. Hmm.
For example, the visible light, it is called white light because it contains multiple wavelengths. Like it will have wavelength corresponding to red color also, which is around
Hmm.
um, it is around 800 nanometers,
Hmm.
700, 800, and it will have wavelength corresponding to violet, which is has lower wavelength around
Okay.
300 nanometers. So it will
Okay.
have the whole range in it. So we call it white radiation. So in case of X-rays, if there is a continuous range of wavelengths, we call it white X-ray. So it will appear as a background because it is a continuous X-ray, not a specific wavelength. And I think I'm not sure about these two options, which
Hmm.
spectrum it will be in.
Hmm. I am not that.
Mhm.
That
I
X-ray.
am not sure what EDS spectrum means. EDS means energy dispersive spectroscopy,
Energy disperse. Correct. Correct.
but
Occurs in
this I'll
wavelength.
have to look into. It's one of A or D.
So I think a specific wavelength, sir. I think. It is a radiation X-rays, but
Mm,
not a specific energy displacement. That is specific wavelength. Know that.
yeah.
Correct. My information. That is a specific wavelength. It is correct. That X-rays, not a specific energy. Correct.
Mhm. So it might be uh, EDS spectrum also. I'll confirm in the next next session.
Yeah. Sure.
What is EDS spectrum?
Yes. Yes.
Mhm. But you understood what is white radiation now, right?
Yeah. Yeah. Please. I
Mhm.
will look that. I am looking once at
Mhm.
that time. Right.
Okay. So we can go to the next question.
Yeah, in a
Question six.
sum, calculate the required BSc and the background secondary electronic current. Achieve the BSc yield of zero point 0.8 for the primary beam current of 2 microampere. Correct? Question.
Yes.
That is a 1.4. BSc's yield is a zero point 0.8. For the primary has been that 1.4. It is also once I check, sir.
Mhm.
I will, sir, I will,
Yeah, yeah. Mhm.
I will.
Which
once
option?
again relook. Option is, I think
Mhm.
that once I calculated better that way of calculate the BSc and SE and versus BSc yield. No,
Yes.
whatever you today explain that SE versus BSc yield ratio for the primary beam of the
Mhm.
current to 2 micron is that I will relook that once again calculation part.
Okay.
Right.
So I'll just explain briefly.
Yeah,
So
please.
yield basically means what is the number, here it is for electron, number generated
Yeah.
or detected
Okay. By.
by the initial number of initial electrons. So here
Yes.
it is the primary electron beam.
Correct.
When the primary electron beam interacts with the specimen, you will have majorly two kinds of electrons which will come out at high
Okay.
intensity. So one will be BSE and one is SE. Both get generated due to different phenomena, and based on this, how much it is generated, you can calculate a yield
Okay.
percentage. So here it is 0.8, right?
Yes.
And so yield is zero point 0.8 here. So we can say that the current is proportional to the number of electrons, right? Because current is generated by the flow of electrons only.
Mhm.
So the amount of current will be proportional to the density of electrons which are generated.
Mhm.
And if the primary beam had 2 microampere current and the yield of BSE is 0.8, that means that 80% of the initial is coming out as BSE,
BSc.
initial electrons. So 20% is getting absorbed, I think. Some inelastic scattering is occurring, and 80% is coming out as BSE. So the answer will be 80% of 2 microamperes.
Mhm.
So the answer will be D, 1.6 microamperes.
Okay. 1.6 or 1.7 microwaves. Okay.
Phonon scattering.
Phenon scattering in electrons is specific interaction. 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 Carry useful chemical information, carry useful contract information, carry useful refraction related information. Scattering. Scattering means is it diffraction related information. Carry useful chemical analysis information, not sir. Carry useful contrast information. Carry useful diffraction related information. This is that. C.
Diffraction related. Okay.
uh,
Mhm. So you understand what is phonon?
Phonon.
Phonon.
It is a electron for passing of that spectrum.
Mhm.
That it is a related to that um, scattering of the electronics. No, that point of view, I understanding that. Phenom.
Mhm. Actually, phonon has to do with the electronic structure of the atom.
Mm, mm,
Um, Basically, what happens is that when you have a atom and you have electron which is approaching the atom at a very high energy, there will be some interactions which will be occurring between the between the atom, that is the electrons of the atom, as well as the nuclei. So this is the nuclei, and because of this, it will there will be some vibrations which will get generated in the atom, and that will lead to generation of heat in the material. So any
Yes.
kind of heating is basically a phonon interaction that is taking place.
Hmm.
So because of this vibration, there will be heat generated, and this phenomena is called phonon scattering. There is loss of energy due to this heat, and
Heat.
this usually does not give any useful information because this is just heating that is happening.
Hmm.
So the answer will be D.
Okay.
It is just causing heat
Else
generation.
contrast information. Correct.
Mm-hmm.
Okay.
Huh.
Scanning mode is and some increase the pixel size, decrease the resolution, increase the resolution. It is does not affect the image. It is increase the pixel size, no?
Mm.
Increase the pixel size or rather increase the resolution. These both of them, I think, these are my little bit differences. I think increase the pixel size. Some scanning mode in the sum. Why because
Mm-hmm.
my subject point of view that chemical phenomena, which is
Okay.
any particle of my pharma industry that scanning mode of some analysis a little bit take a particle size point of any molecule to
Mm-hmm.
some analysis to depending on that pixel sizes
Okay.
that I made maybe I think my as per guide the increase the
Mm-hmm.
pixel size my answer. If anything, please explain that. Fine.
Mm-hmm. Okay. Actually, this question is not a very straightforward question
Yes,
because in SEM you always have scanning taking place.
correct.
Like there is an electron probe and it is being scanned on the specimen surface. You get
Surface.
the image of the scan area.
Correct.
But that should not have an effect on the image, I think,
Not in image,
because
not in the
scanning should
resolution.
not change the and the resolution or pixel size should not be affected. So I think the answer should be doesn't affect the image. I will have to recheck this once,
Okay.
but most likely this should be the answer because the resolution or pixel size will depend on how the interaction is happening. What is the size of the electron probe?
Electronic probe.
If you have this material, what is the size of this electron probe? Because
Okay.
this will generate the signals, and also what is the interaction volume or sampling volume from which the signals are coming out.
Okay.
If the interaction volume is more or the probe size is more, in that case the resolution will be less because it will come information will come from a bigger area.
Okay.
But scanning should not affect it, I think. Also, pixel size should not be dependent on the scanning. So I think it might be D.
Okay.
Hmm. Okay.
Okay.
So then let's go to ninth question.
Elastic scattering occurs mostly in background detection, BS yield, that backward direction, the direction of higher angles. Backward direction involves the deflection on the smaller red. Forward direction involves the deflection higher angles. Forward direction involves the deflection. in a smaller. It is both of them. Background is the higher and smaller, and forward to the higher and smaller. Elastic scattering is occurs. It is a little bit my that doubt confusion. That background is one is that higher and lower, that forward to that higher and lower.
Actually, this is question is repeated, I think,
Mm, mm,
because
mm.
it was here also, no, elastic scattering.
Mm, mm, mm.
So I had told that nuclei is very small, so reflection due to this repulsion with the nuclei, which happens in
Okay.
elastic, that is very rare because the nuclei
Mm,
is very small. So the angle of deflection is very small in most cases.
mm, mm.
This is clear to you,
Yeah, clear
this
to
question?
you that the deflection involves the discussion. Elastic scattering, the deflection. Forward
The
to
answer will be in, the answer will be D, same answer.
say, okay.
If you have doubts, you can try like going through the video lecture. There in detail, all
Sure.
of this will be explained.
Okay.
Mm.
BSC signal from the specific one is capable of yielding information about BSC. This is the electronic structure, sir. My as per listening. Yes.
Yeah.
Yeah. Is that right or wrong? I don't know that. Please, if anything wrong, I will please explain that. BSC signal from the specific that capable that electronic structure.
Yeah. So yeah, we know that surface topography information comes majorly from Se electrons,
Yes, correct.
and BSc can tell you about the atomic number of the elements.
Correct.
So electronics structure is only partially right because it does not tell about the electronic states of the atoms.
Okay.
It tells majorly about what is the nuclei of the atom. So I think composition will be more right
Okay. Okay.
because it does not give you information about what is the electronic state of the atom, how the electrons
Yes.
are
Yes. Yes. Correct.
around the atom, right?
Correct. Correct.
Mm-hmm.
In a SEM, in a SEM, scanning electronic scanning electronic that mode smaller that and cost levels of detector, smaller spot sizes will where the lower brightness and contrast levels in the detector. Spot size doesn't affect on the constant the detector. Spot size doesn't affect on the brightness in the detector. It is a A.
Okay. Okay. Mm. I'll also have to think about this question.
Mm, mm.
Mm. Okay, I'm not sure about this.
Okay.
Hmm. The spot size majorly. So as I had shown in the previous image, no?
Mm-hmm.
The spot size tells you how much of the region of the specimen is interacting with the incoming electron beam. So if it is smaller, the interaction will happen in a smaller cross section, and there will
Mm-hmm.
be a the interaction volume will also have a smaller neck here.
Mm-hmm.
But mm, I think brightness is affected due to the intensity of generated electrons,
Mm-hmm.
like how many electrons are detected by the detector. The more the number of electrons detected, the brighter you will have the image, because more current is coming, right?
Okay.
So brightness is connected to that.
Okay.
How much is the difference in the intensity corresponding to them? Because we can only get to know about the specimen features based on the difference in the intensity in the images. One is dark and one is light.
Mm-hmm.
Then you can tell that there is some feature, right? So
Mm-hmm.
the contrast tells you how much is that difference.
Okay.
So I think brightness will be affected because for smaller probe, it's likely that number of electrons coming is less. So those which will go out will also be less, right?
Mm-hmm.
But contrast
Mm-hmm.
should not be affected. So should not. I don't think it should have an effect due to the spot size.
Okay.
I think the answer might be C, that the contrast will not be affected by the spot size. The brightness can be affected.
Okay.
Um, Though I'll just confirm what is the correct answer later on.
Mm-hmm.
But I think it is C.
Mm-hmm.
Hmm. Let's go to 12.
12th also. I think 11th ka opposition question, sir. Abhinav. Abhinav. I think correct. This is the 11th ka pure
Hmm.
opposite, no? This
Okay.
answers. This answers. I think 11th, all what are the alphabetical A, B, C, D. This is A, B, C, D ka pure opposite like that. Am I right? If anything, I will correct.
In 12th, you are saying?
Yeah, 11th or 12th is
Hmm.
question is same, but answer is a little bit difficult for that opposition that.
Hmm.
That
Okay.
magnification, that
Hmm.
greater than the magnification current, that smaller than the larger than that, the middle range that of that.
Hmm.
Uh,
So here they are asking
Displacement. Now that is the
how is
dimension that.
magnification related to the rastering or and the size of the display of the screen.
Correct.
So
I
that,
think
yeah,
it
yeah.
will be
Mhm.
the larger the term.
Hmm. So here, should I explain?
Yeah, please, sir.
Hmm. So do you understand rastering, raster dimension?
Rastering. Yeah. Raster dimensions. Please.
Okay, so this is related to. I'll show the slide where we have the figure for it.
Okay.
Yeah. So So if you have a specimen like this,
Okay.
then this is the area where you are doing the scanning.
Okay.
So this is your specimen scan area.
Okay.
The probe will move like this in a linear fashion, one by one.
Okay.
And as it is moving, there are signals getting generated, right? SCs, BSEs, X-rays. So they are
Yes.
detected by the detector.
Okay.
Based on the intensity of those signals, it
Okay.
will make an image. It will You'll have a display screen, no, CRT display. So
Okay.
on the computer, it will make dots, basically pixels, for each point where the scanning has occurred.
Mm.
So there will be one-to-one correspondence for each point. Whatever signal came from there, that will be used to make a point on the CRT display.
Okay.
And in this fashion, it will create the image line by line.
Okay.
So the rastering on the specimen scan area is
Okay.
directly uh, causing the generation of image in a similar fashion, line by line.
Okay.
Okay, so that is how image formation is taking place. And
Okay.
now, if we look at this question, if the if we want greater magnification, that means for our size of display, the
Okay.
area that is coming, the scan area of the specimen which is being used should be smaller, right? If it is
Yes.
this small and it is being shown in a bigger screen, that means
Okay.
magnification is higher.
Okay.
For example, if this is 1 micron
Mm-hmm.
and this screen is, let's say, zero point 0.1 meter, so we
Okay.
have a almost 10 raised to 5 times it is being magnified, right?
Okay.
So if we want higher magnification, we should have a smaller scan area and a bigger display screen.
Okay.
So the correct answer should be smaller raster dimension, larger display will lead
Mm.
to greater magnification, right? Because
Mm.
there is a small feature, you are zooming it up on a big screen, right?
Mm.
A very small area is being zoomed on a big screen. That means magnification is very high.
Correct.
Mm.
That is the C. Okay.
Yeah. Mm.
Choose the most appropriate one.
Yeah.
Choose the most appropriate one. SE1 electrons are produced by the primary electronic and beam impacting up in the specimen surface clearance the narrow escape depth. SE1 electronics are produced from the depth inside the specimen due to that primary deflection of that That primary electronic specification in this SC1 electronics to produce the big end of the specification. Imagine that the AC1 electronics are produced at the depth inequality the specification do the Baxter electronic specification. This is also a little bit confused, Abhinav.
Mm-hmm. Okay, yeah. Mm-hmm. So, uh, you understand SE1 electrons?
Yeah, little bit.
Mhm. So SE1 electrons are those which are generated by the primary beam.
Primary beam, correct?
Mhm. So when you have a primary beam, so either there can be some BSE electrons which are backscattered at high angles. So even they
Okay,
can generate SEs here. Like
okay,
at this part, when they are near the surface, they can generate SEs.
okay,
Or the primary electrons itself can generate SEs. So this, if primary electron is generating, it is called SE1. If it is by BSE, we denote
okay,
it by SE2 to just differentiate between them.
okay.
So the answer is SE1 is corresponding to primary electron beam impinging the specimen
Mm-hmm.
surface, and since it is from a secondary electron having low energy, it is always from near the surface. So
Okay.
it will be characterized by narrow escape depth. Only from a small depth it will be able to escape.
Mm-hmm.
Okay.
Yeah.
So let's move to 14.
Some and team different. Some is scanning electronic. That term is electron. That term amazing technique. The way of imaging technique, contrast generation of performing the magnificent. The way of imaging technique and performing magnification. The way of performing the magnification and contrast generation only. The way of imaging technique only. The way of imaging technique and performing the magnification, sir.
Okay, okay. Hmm.
The way of
Hmm.
the way of imagining technique and that performing that magnification is, I think, my answer, sir.
Hmm.
Technique. It is a
Hmm.
SEM and a TM difference, no? That is the both of it.
Yes. Okay.
Difference is T.
Hmm. Okay. Yeah.
Yeah.
So the imaging technique is different in both
Yes.
because in one you have transmission and one you have just mm, generation of electrons, and those
Ah.
are detected. In the other one, the transmitted ones are detected. Also, so the lens arrangement is different for both of them because of this.
Mm,
But here in imaging technique,
mm,
in case of SEM, we know that imaging occurs by rastering. So line by line, the image is generated
mm,
based on the signal detected. In case of TEM, we have diffracted the transmitted and diffracted electrons, which are captured on a screen, fluorescent screen, and
mm,
based on the that we have formation of diffraction, some diffraction spots, as well as a central transmitted spot, right? And so it can either be this, the Mhm. so we have this kind of a diffraction pattern that we get on the screen in TM, and in SEM we get just rastering,
mm.
the rastering related image formation. So the imaging technique is different. Then
Hmm.
magnification is also different, because in SEM you just zoom in on the scan area. Just zoom in. You just zoom in by mm, using a
Technique.
smaller scan area and a larger display. But in TEM, the magnification happens by changing the lens strength. So this I also told when recapping the in to week 6 lectures. So here
Hmm.
in TM we have lens strength, the strength of the lens being changing. So the focal distance is changed, so that you can
Hmm.
change the magnification, converging it more to magnify it more. So
Hmm.
magnification also changes, but the contrast generation will also change. In SEM, the contrast is generated by having different number of electrons coming out
Hmm.
from different areas. From the
Hmm.
surface, more electrons will come out from somewhere below, like from if the surface is not even, if it is a bit undulated like this,
Hmm.
from
Hmm.
those higher regions, peaks, there will be more electrons coming out, because it is closer, because it is easier for electrons to come out from these areas, while from the lower valley regions less electrons will come out,
Hmm.
because they will get absorbed in the specimen, right, the secondary electrons. From peaks it will be easier for the secondary electrons to escape. So
Okay.
this leads to contrast generation in case of topographic imaging. But in TEM, the contrast generation occurs because some features are there in the specimen which are of a higher atomic number, or there are some defects in the crystal,
Hmm.
right? So at those defects, diffraction will uh, so at those defects the interaction will be different. The diffraction will be occurring at a different angle because of some strains at the defect area. So
Hmm.
because of that uh, defect in the material, you will have some contrast generation. So contrast is either due to the atomic number difference or defects in case of TM. In SEM, it is due to the surface related characteristics.
Yes. Correct.
So the answer will be
Yeah.
A.
Yeah.
Yeah. Now
Correct.
coming to the last question.
The contrast produced in the some images. Therefore, we have elements in the secondary mode, lower for the heavier elements in the backward mode, lower for heavier elements in the secondary mode, higher for the heavier element in the backscatter mode.
Hmm.
Either A and D, sir.
A or D. Okay.
Yeah. I think not second. I think background BSC. I think higher for that D. I think the
Hmm.
contrast
Okay.
produced the sum secondary element, that scanning element of that image is that higher heavier that elements in the backscatter mode. I think maximum 90% is a D or
Okay. So let us try to understand this. Mm. There will be a contrast when when heavy elements and light elements will have a
mm,
different effect on the BSE or SE electron
mm,
generation, right?
mm.
So
Correct.
if lighter elements generate in a different way, in that case we'll
Okay.
see a difference based on the atomic number.
Okay.
Uh, but we know that SEs do not SE generation is not affected much by the atomic number, because it
Okay.
is basically electron getting knocked out from the atom, from the material atom,
Okay.
and which is near the surface. So even if
Okay.
the atom is of a different element, the effect of it on the generation or yield of Se is not much. But
Mm.
BSE involves interaction with the nuclei of the atom. So
Correct.
if the element is heavier, the nuclei will be bigger, it
Mm.
will have a higher charge, so the
Okay.
interaction will be more. So
More.
BSE yield is more for
More.
heavier
SC.
atoms. BSE,
Yes.
because it is a elastic interaction with the nuclei of the atom, so yield will be dependent heavily on the element, atomic number of the elements, and so the contrast will be, there will be more BSE generation for heavier elements. So in backscatter mode, for heavier elements, the contrast will be higher. You will
Yes.
get more number of signals for the heavier elements.
Yes.
So we can say that the answer will be D, higher
Yes.
contrast for the
Yes.
heavy elements in BSE mode.
Yes.
Uh, so the assignment for the week is completed now.
Yeah. Thank
Mhm.
Just
I
today
think we
evening,
can, yeah, we
yes,
can wrap up this session now.
yeah, wrap up. Not an issue, sir. I think correct.
Mhm.
Very good. Thank you very much, Abhinav. Excellent.
Mhm.
This is the first technique, technique of material characterization. First, I will suggest that. Abhinav, thanks a lot for
Mhm.
that. Your good explanation also give that. Each
Oh,
and every doubt and myself and each uh, point of view them. Uh,
mhm.
if any also if it is a good manner for a very passion and your specific
Mhm.
time also that very interact with you that better to my
Mhm.
to continue that ligand that further previous also I try with our as per our notice for if any possible for previous 5 assessments also I will took a manner for that
Mhm.
NTPL team this exercise assessment 6 also today end of the day or tomorrow morning I will submit you that.
Okay. Okay. Thank you,
This is the
Mutyal.
thank you Abhinav.
Thank you
I
for
will wrap up.
interacting
Yeah,
and answering on the assignments.
yeah,
So
yeah,
I hope that this was helpful. Also, you can, now you have some idea regarding the portal and the discussion forum.
correct.
So you can try to use that.
Yeah, thank you.
Thank you for
Thank you.
attending.
Thank you, Abhinav. Once again.
Okay.
Bye.
Bye.
Bye. Right up. I will touch.